All right, so last week I made a demonstration of how to write an interface for something that you don't yet have. Now I want to look at the problem sort of in reverse. Imagine, like most times, you're working at a place and you inherit a project and you get this kind of monolithic component. What I mean by that is you have a one project with a gazillion classes. This might be a simplification, but so often you might get a DLL with hundreds of classes and everything calls everything, and there doesn't seem to be any line of delineation, no boundaries between, no proper namespaces that scream the architecture that of the business rules. Um, so what I want to talk about today is a strategy to use interfaces to create the boundaries in an existing project. This time I'm going to stay focused in the drawing tool. I won't actually show code, and I'm going to try to do this in a really short amount of time. So I would say buckle up, and here we go. So imagine you have a project, like I'm calling it a monolithic component, but let's say it's I'm going to use the same example that I used last week. Let's pretend it's some sort of workplace application. And when I call it a policy component, I mean, this is a component that has all of the business rules. It's the most important thing in the world. This thing can't be compromised because everything depends on it. Well, it's the only component in the application, so naturally it is the policy component. Let's imagine you have one of these concrete classes. Let's start relabeling things here. Imagine this is a class that encapsulates the workplace logic, at least as well as it can. We'll assume that there's some sort of separation of concern in these classes. Probably not, though. There's a lot of coupling in most classes you might inherit. And let's say I'll call it a school. Okay, so what this application is doing is somewhere in the midst of this monolith, there's some sort of code in here that is, let's say, a workplace class that is calling a school class, and it says, hey, give me one of your students so that I can recruit them, and then I can turn them into an employee. Maybe this portion of the application, if there were to be a namespace, would be the recruiting portion of it. But it's hard to say because it's sort of monolithic and there's not a lot of organization. There's also very little separation. As you can tell, there's no interfaces yet at this point. I'm going to delete all the rest of the classes just so that we can focus on the portion that we care about. So what we've done here is we've created a diagram just of the pieces that we care about. We know the other pieces exist, but we want to kind of create a boundary for these elements. We see there's no other dependencies, and this is kind of nicely isolated. Now, the first thing we would want to do is we want to look at what is the school doing for the workplace. Now, school might be doing a lot of things. There might be many classes that call school, but specifically the thing that workplace needs from school is recruiting. So what we would do is from school, we would extract some sort of interface, and maybe we'd call that interface the thing that it is doing for the workplace. So I would propose we would call it a recruiting interface. And we would have the school implement that interface. Notice at this point in time, the workplace is still calling recruiter, and now the school is implementing the recruiter interface. The key here is we could simply go to the school class and we can extract an interface, especially if you're using Visual Studio. There's probably some utility. You can right click on the class name and extract it based on all the method names available to the school. But what I would do is I would recommend that you only extract the methods that it means to do recruiting. So school might have, let's say, 20 methods, but workplace is only calling 2 or 3 of them. Well, that recruiter interface should only have those 2 or 3 methods that it means to do recruiting. And what we do here is we reduce the footprint or the dependency of workplace on school. So workplace only cares about the recruiting aspects of school. And I'll go ahead and delete this component diagram for a second. Actually, I'll just put it to the side. We can use that later. We're just focusing on the classes. So just as school depends on student, recruiter would depend on student. So what is going to happen is workplace is going to call the recruiter, and the recruiter is going to return a student. Well, maybe from the recruiter's point of view, it's not really a student, it's just a recruit. So we could rename this to recruit. I'll just kind of put this to the side here for a second. And maybe student is a type of recruit. So recruit would act as a base class for student. So when workplace calls the recruiter to get a recruit, school would return a student. In this case, school would no longer need to reference recruit directly. It would reference school. School would generate a list of students or a student and return it through the recruit. And then the recruiter would return this recruit model to the workplace, and workplace would convert it into an employee. Maybe we don't like using base classes. Maybe what we really need is an interface, because you could have several kinds of students as long as they implement the recruit interface. Let me rephrase that. You can have many kinds of recruits. A student is one of them. You might have someone come from a boot camp. You could have someone come from off the streets. They don't have to be a student, but they would have to be a recruit to be returned by the recruiter. So what we've done here is we've created a boundary. So now this interface is acting as a boundary between the workplace concerns and the school concerns. It just so happens that school implements this recruiter. So this is a way to create a boundary within your monolith. Now, what this allows us to do is maybe in the future, we want to extract school into its own component. We could take Now what we've done is we've taken the school components out of that monolith, and we've created a component just for school. And in this case, because the policy component depends on this recruiter, anything that implements it becomes a plugin. So we haven't changed the code at all. All we did was add boundaries, and that boundary gave us the freedom to extract a separate component. Now, what if we wanted to swap that component? Let's say instead of a school, we wanted boot camp. Now, the workplace could depend on calling this recruiter that is implemented by the boot camp. The boot camp would return a boot camp student that is implements the iRecruiter interface, and the workplace would still get that recruit back, it would have no idea that it was a boot camp that implemented um, the recruiter interface as opposed to the school implementing the recruiter interface, and then it could just map it into an employee. From the workplace's point of view, no business rules have changed. We've just swapped the implementation of the interface. That's the power of having a boundary between the two components. Earlier, before we extracted school out of the monolith, we also had value because not only did the interface give us future ability to swap, but it also allowed us to create mock objects and do unit testing for the workplace, so we could ensure that we had 100% code coverage on the workplace without having any dependencies on the actual school or student models. Another thing we could do is we could extract an adapter. Let's say that in this case, the boot camp isn't a plugin. Well, what that means is whoever's developing a plugin, they have a dependency on this workplace policy component. That means that if a third party were to deliver a boot camp, they would have to know how our code works. In the real world, that's never going to happen. So usually boot camp is going to be its own thing. So a boot camp class might be called and it would return boot camp students, but it doesn't care who calls it. It just expects to be called. So this thing, it would have to be called by some sort of adapter. In this case, we know that we need a recruit. It didn't have to be an interface. Well, actually, let's keep it as an interface. Our adapter component, we'll change it to adapter. It stays a detail plugin component. And those interfaces are usually indicated by dotted lines. So here we have a boot camp student that the boot camp is returning. And in fact, this doesn't even have to be a boot camp student. It could just be a straight up recruit. So from the boot camp's point of view, all it knows is something is going to call it, and it's going to return a boot camp student. So there's some adapter in the middle here that says, okay, I know about boot camp, and I know that boot camp is going to return a boot camp student, and my job as a boot camp adapter is to convert that student into some sort of recruit, and this recruit is going to implement this recruit interface, and I'm going to implement some recruiter interface so that when workplace calls this interface that is implemented by the adapter, it can trust that it's going to get some object back that implements the recruit interface, and then it can convert it into an employee. So the value here, as you can see, the code gets a little more and more complicated. So here, the school has been split out from the workplace. That allows us to develop school at a separate cadence than workplace. Here we've swapped school with a boot camp. So the value is that if we decide we no longer want to implement recruiting with a school, we can implement with a boot camp or something other than school. But the negative here is that the thing that's doing the implementing has to know about our code. If we are depending on some sort of third-party component, like in this case, you might have a third-party boot camp DLL, well, the way we implement that is we can have a boot camp adapter. The benefit of having an adapter is that this workplace component doesn't have to depend on boot camp. It can just sort of live in its own world, and we keep it decoupled from everything by using an adapter. But we could go in reverse. Let's say we're over engineering this a little bit. And what you can do is, let's say we don't care that the workplace has a dependency on this third-party bootcamp DLL. That bootcamp adapter can still live inside of the workplace component. And of course, it can have the recruit model that implements the recruit interface. All we've done here is just move the boundary from here to here. The important thing that you see is that the classes themselves didn't actually change. What changed was the boundaries between the components. So here we have several options. So going back to the beginning, we had a monolithic component, and we wanted to improve a portion of our code using clean code and clean architecture practices, and everything was all kind of dependent, and there was the high level of dependency, but by introducing interfaces between the boundary, creating boundaries with interfaces, we were able to clean up some of this code, which gave us benefits for unit testing, swappability, decoupling, dependency inversion, or straight up just being able to implement third-party components to do a thing. So there you go.